Здравейте, казвам се доктор Медицински от Медицински център Феникс, град Пловдив. Днес се намираме в Литва, в изследователската лаборатория на доктор Адас Даринскас в Росет, и днес ще разгледаме мястото, на което се случва магията, там където се извършват проучванията. Това е първата лаборатория на Росет, нямаме достъп до втората, тъй като тя е много по-осъвременена и има по-контролиран достъп. Не можем да снимаме, за съжаление, с камери вътре, всичко е стерилно. Тук се извършва процеса на създаване на технологията с стволови клетки, намножаването им, извличане на екзозоми и много други неща. Can you explain to us what is the general practice around here in this lab, and how do you expand the stem cells, how do you extract the exosomes, and so on, just to get our patients to know where the products that we're using, the medical products that we're using for treatments, where it's coming from, and that it is perfectly safe for use and doesn't have any issues with the government and within production.
Yeah, we are absolutely legal here. So the first stage is to make everything like in the R&D step, research and development. Then, and this lab is doing this. So we are just developing and and creating technologies here. So like how to cultivate regular stem cells, mu stem cells, how to develop NK cell technologies and cytokine-induced killers or any other immune therapy stuff. So this lab is mostly like accommodated to do scientific research and upscale, like production process. The clean lab is in another building. We have like GMP certified and qualified laboratory with all people enrolled in that. So we are regulated by European Union, like licensing and everything else. So it's just another question, which is boring one.
Yeah.
But yeah, we have like permissions to work in cell therapy field in Lithuania. So we have like products which we can use in patients. So this is what we do. But here we produce only things we use in research and development.
Значи, това, което нашият колега каза, е, че тази лаборатория е изрично за проучване и за създаване на нови технологии. Чистата лаборатория, в която вече се създават самия медицински продукт, който използваме заедно, тя е off-limit за нас, т.е. ние не можем да влезем вътре, тъй като достъпът е много лимитиран и вътре стерилността е на много по-високо ниво. Can you show us around where the stem cells are expanding and explain how much time they need to pass until it's one expansion is done after the other, and when is the time when you collect the exosomes and so on?
So actually the crucial thing is the source. So source is like umbilical cords of healthy donors. It's regulated by our public cord blood bank. We get the material there, like from volunteers, free of charge. And then we proceed to like isolation of the cells and cultivation of the cells. There are like two types of cells you can produce. It's like mu cells, which are produced in bioreactor, and non-mu cells, which are produced in like regular flasks or like on a flat surface.
Това е биореактор, в който се произвеждат чисти мюс клетки. Това там е... Нека да го покажем. Това е инкубатор за нормални стволови клетки, МСК клетки и така нататък, който произвежда клетките в плоски повърхности с хранителна среда. Yeah. And the production of new cells is really hard.
Yeah, it takes time.
It takes time and it needs certain conditions for them to be able to isolate the new cells, right?
Yes, they grow very slowly, and that's why this makes the process a little bit complicated. So it's long-lasting process, but 3 or 4 times longer than regular stem cells.
Yeah. Значи, това го обяснява колегата, че мюс клетките отнемат 3 до 4 пъти повече време за експандване, т.е. за намножаване от нормалните стволови клетки. Okay. And how do you extract the exosomes from the stem cells?
It's like milking a cow. So the same, yeah, really, because the exosomes are produced in the media by stem cells.
Yeah.
And this is the piece of art to collect the media and to like make exosomes concentrated from this media and produce them into the drug. So this we do by filtration procedures. We do not do the ultracentrifugation because it harms the exosomes. So we have like a well-developed process of ultrafiltration, not ultra, just filtration, gel filtration, and then freeze-drying process of the final product.
So, това, което каза Алес е, че си е цяло изкуство да събираш екзозоми на стволовите клетки, тъй като екзозомите се отделят в хранителната среда, в която се намират клетките по време на своята експанзия. И по този начин трябва да се... Общо взето го обясни като доене на крава, тъй като точно това е процесът, който се случва по време на самата експанзия на клетките. Взима се част от матрикса, който е междуклетъчното пространство, докато те се намножават. После екзозомите се филтрират многократно и се изолират, след което се леофилизират и се превръщат в медицински продукт. Okay, so what other things do you develop here? Like for research purposes, peptides, I think as well, or something else?
We develop technologies which involves exosomes loaded with some drugs for directed response. So this is like mostly some kind of delivery vehicles to the site of where it is necessary.
Значи това, което обяснява той е, че тук използват, правят опити с различни лекарства в комбинация с екзозоми, като екзозомите служат като допълнителен транспортьор за лекарството, то да отиде точно където има нужда, за да може с по-малки дози лекарства да има по-добър терапевтичен ефект. And this reduces the dosage of the drug.
Yes, for example, if you have like chemotherapy drug which is like toxic, for example, doxorubicin, a very good chemotherapy agent, but if it's cardiotoxic. But you can put it into exosomes and reduce the amount of administration to nanomoles. So this means that you are killing only cancer cells, not healthy tissue cells.
Yes. Same with nivolin as well. For neurological diseases, you can reduce the hepatotoxicity by adding some exosomes and reducing the levels of the drug.
So that's why we're using this as transfer vehicles.
What about the NK cells? How are they developed? How are they produced? And
we are developing also updating the technologies we're doing. They are grown in such kind of vials.
The circular ones.
Circular ones in the buckets. And we go for specific expansion methodics and searching for their tumorigenicity, how they can kill tumors. So this is most convenient system for us.
Yes, and not only tumors, chronic infection diseases as
also,
well.
And CAR T cells also can be produced in the same way. So we do also have CAR T cells, but we just under R&D only. But
Of course, but the NK cells are really a new, not like a new, but on the...
Can go as senolytic and infections control agent. So that's very good actually approach.
It's a good immunotherapy for patients.
Because your immune system also get old. So that's why you need some support.
Of course, but most doctors, if you tell them that you want to inject NK cells into a patient, they're gonna go back off. Like immunotherapy is scary for most conventional doctors.
I remember my first time of immunotherapy with NK cells. It was scary because there is no information about them, and everybody writes that growth versus graft disease and all conditions like cytokine storm and everything like that, but not for NK cells. NK cells are really very well tolerated.
Yes, and the other thing that the patient might experience might be on the next day, when the therapeutic crisis becomes when cells start dying from inside our body, you get intoxicated and the patient thinks that
it's not a lot of cells. We just give 1 billion. And 1 billion, you usually get rid of 80 grams of dead mass.
I know.
So
it's a lot.
It's a lot. So 1 billion cells is I think 0.2 grams. So nothing about it.
But I'm thinking about after they enter your body, they start killing either
have a bigger burden.
Either cancer cells or bacterial or parasitical cells, which the cancer cells are not that toxic, but the bacterial cells, they have endotoxins and so on, which are going directly into the blood. So the patients are going to feel a little bit down for 2 to 3 days, but after that they start feeling better and better because the infection starts to be better controlled.
Yes.
Тук що говорихме за natural killer cells и вливките на...
Also exosomes from natural killer cells can be used
Of course,
for cancer tumor, cancer treatment purposes.
Значи, говорим за natural killer cells или клетките естествени убийци, които са неизменна част от нашата имунна система, но с годините или поради друга причина, поради друг имунодефицит, нашето тяло има намален брой на natural killer cells, което си е разработена технология, която ние прилагаме за повишаване на имунния статус, за третиране на туморни състояния, за хронични инфекции, без значение паразитни или бактериални, от което тук ще се обсъдихме смело терапевтичната криза, която се случва след вливката, тъй като умирането на чужди организми или на ракови клетки в нашето тяло е съпроводено с изливане на много токсични вещества в кръвта, което преминава за от 1 до 2 дни, тъй като тялото трябва да ги изхвърли. Това са отпадни продукти от чужди клетки, може потенциално с токсини при бактериалните инфекции. Така че да, и те, като се прилагат с natural killer cells, се прилагат заедно с екзозоми, конкретно към лечението на туморни заболявания. Окей. Thank you very much.
Bye.
Bye-bye.